And welcome back. As we go ahead and continue to jump into our next topic, which is that of file I/O, we're going to go ahead and review a little bit with text file input output, which we have looked at before, but we're also going to get ready to introduce binary file I/O, which is going to be something a little bit new for us. So let's just recall our file I/O from before. We covered kind of the most common ways of doing file I/O in Java. However, it's not an exhaustive study of the Java I/O classes. In fact, the library is so large that we could literally just send a whole course just looking at all the different ways we can start handling file I/O. In fact, we start thinking about things like GUIs and stuff like that. It really starts adding to layers of complexity that are going to be beyond the scope of what we're covering here in this course. However, before we deep dive into anything related to file I/O, we're going to take a quick recap on how file I/O works and also look at the difference between the text file and binary files that we're going to be using. So the first thing to recall is this concept of streams. Now, a stream is simply just an object that allows for the flow of data between your program and some input-out device or maybe a file. If the flow is into our program, then that stream is known as an input stream. If the input stream, for example, flows from the keyboard, then your program will take input from the keyboard. If the input stream flows from a file, then your program will take its input from that file. Conversely, if the flow is out of your program, the stream is an output stream. An output stream typically is going to either run to your screen, so it's going to be displayed in some way, such as through the console, or it's going to be output into like a file. Now, we have already seen some of these so-called streams. System.out and System.in, of course, are two streams that we're already familiar with. System.out, which we use very often, is System.out.println or System.out.print, is an output stream that's connected to the screen. System.in, which we are very familiar with from using the scanner class, is an input stream connected to the keyboard. And we've used System.in in expressions such as following: scanner keyboard equals new scanner System.in. Now, these two streams, System.out and System.in, are automatically available to your program. You don't have to have any special import statements or anything like that. They're automatically available and we can use them right off the bat. Now, we can define other streams that can come or go from files. And once we kind of define these other streams, we can then use them in our program in ways that are similar to how we use System.out or System.in. Alright, so enough talk about streams. Let's look at the actual difference now between a text file and a binary file to really help us differentiate what these are and what purpose they have. And you might be able to kind of derive some of that just from their name. But text files are files that appear to be sequences of characters. So we can open these up, for example, in a text editor, and we can read also them by a program. The files that contain our Java files, for example, are text files. So if you were to take the .java file and you could open that, for example, in Notepad, you will find that that file, of course, is readable. Text files are sometimes also known as ASCII files because they contain data encoded in a scheme known as the ASCII coding. So if you're familiar with the ASCII character set, that's what they're very often using. Files whose contents, however, handle a sequence of binary digits are known as binary files. And as we go and compare text files versus binary files, the best way to approach this is to think of as text files containing a sequence of characters, and a binary file is containing a sequence of binary digits. Now, this is not an exact translation of how they are and how they work, but for our purposes in discussion right now, this is the best way to think about it. Another way you can kind of distinguish between binary files and text files is to know that text files are designed to be read by humans, whereas binary files are designed to be read only by programs. So you can't, if you open up a text file, it's going to look like gibberish to you because, again, that's not designed for you to read. It's designed for the compiler and stuff like that to interpret. Now, there are strengths and advantages of both types of files. Let's start first with text files because that's one that's a little bit more easy for us to understand. An advantage of text files, of course, is that we can read and write to them using a text editor. Like, for example, if I have a script and I don't want to fire everything up, I can just go ahead and go to that text file, open up, make some quick changes, and off we go. Another advantage is that they're usually the same on all computers. So we can take that same text file from, let's say, a Windows device and take it over to a Mac or Linux and stuff like that. And we have few to no problems. There might be a couple things sometimes that we run into where you might have to adjust a couple things, but generally speaking, they're going to be treated the same. Now, with a binary file, it has a couple of comparative advantages. First off, that you have to understand though, with binary files, all the reading and writing must normally be done by a program. You can't read and write yourself to a binary file. Some program has to do that for you. The implementation of binary files also usually differs from one computer to another. So your binary data files ordinarily must be read on the same type of computer, so such as a Windows machine, and with the same programming language, such as Java, as the computer that originally created that file. So you can't take a Java file, for example, create it on a Windows device and say, you know, I want to go see how this works on a Windows device that's using C++, because they're going to be two different programming languages. Now, there is a benefit to binary files in that they are much more efficient to process than text files. Because they're in binary, it's already a language that the computer can interpret and use a lot easier than a text file, which it needs to do that conversion for. And unlike other programming languages, Java has a key advantage here, is that it gives its binary files some of the advantages of text files and how it interprets it. In particular, Java binary files are platform independent. That is, with Java, you can move those binary files from one type of computer to another, so I can take it from a Windows device to a Mac and vice versa, and your Java programs will still be able to read those binary files. This gives us some of that portability of text files. Like I said, you can take it from Windows to a Mac, etc., with the efficiency that we associate with binary files. Alright, and real quick, let's go ahead and take a recap at some file I.O. here. So this is two programs that we had in Programming 1. This is a very simple file input here, which is going to simply read in from this numbers.txt file. And then we have a very simple output program here that's going to read from, or should I say write to, not read, to this phrases.txt file. So if we take a look here, we of course have some import statements that we need to manage here. And of course we have down here some, code. You'll notice we have our try catch blocks right now. We did this in Program 1. We like, hey, you just need to have these in here. Don't worry. But now we have a good understanding of what this try catch is doing. It's looking for a file not found exception. We know how these work. So let's go ahead and run this program. Again, this is nothing we haven't seen from Program 1. So I'm just entering a phrase here. So I'm just going to say hello. Program's going to complete the writing. So if you look at how this is, the first number is 1, 2, 3, 4, 5. So it's reading in here with this file in.nextInt. And of course down here it's writing out with this file out. So these of course are very similar to, remember I said we have our system.out and our system.in. You can see here I have a file in and a file out. Those of course are determined in case here by our scanners. So we have a scanner here and a print writer. So these are two different classes that we are going to get familiar with in this upcoming lesson if you aren't already familiar with them. And if I were to open up, for example, the phrases.txt file, I'll open up numbers as well. Numbers, you can see it says 1, 2, 3, 4, 5, 6, 8. And of course, if you look, that is exactly what's being read in with that file input stream. If you look at phrases, that is the output stream. So you can see here's hello, which was the word that we entered in as a phrase. Then you can see we have, of course, a couple other things, which says my favorite double is this. And the product of two numbers is this. So if we go ahead and look, it says my favorite double is, and this is of course just writing this out. And then we have a file output stream, which is simply doing a product of two numbers and then closes that stream. So that of course is a quick overview, quick recap of some of the things with file I.O. We of course are going to dig deeper into that over this unit, and we are going to again take some of these things that we might already be familiar with text files and apply some of those things over to binary files.